So we continue here with two examples, and what I want to make sure that you're comfortable with are the first 5 steps to graphing a rational function. So I'm going to ask that you factor each one of these completely, you find any X and Y-intercepts of them, and any vertical and horizontal asymptotes. So let's start with number 1 over here, which is g of x equals x plus 3 over x squared minus 4. The first thing we're going to do is we're going to factor it completely. My numerator is linear, I'm going to leave it alone. My denominator is quadratic. So I'm going to rewrite this as x plus 3 divided by x minus 2 times x plus 2. We have the difference of 2 squares here. So in terms of factoring, I'm done. I took care of part A. Now let's take a look at part B, which says find the x and y-intercepts. Let's take a look at the x-intercept. Now the definition of the x-intercept is the 0 of the numerator. So what that means is I'm just going to head over here to the numerator, and I have x plus 3. I'm going to set it equal to 0 and solve it. So we'll call this part A. Part B, for the x-intercept, the zeros of the numerator, and we're done. This is telling us that I have an x-intercept at -3, which is telling me the ordered pair -3, 0 is on our line. So there's the x-intercept. Now the definition of the y-intercept, we're going to substitute 0 in every time we see an x. And you can substitute it into the factored version, into the unfactored version. The answer is going to be the same. It's just easier to start with the unfactored version. So in order for us to find the y-intercept, let's substitute in 0 every time we see an x. So I have g of 0 equals 0 plus 3 divided by 0 squared minus 4, which is the same thing as saying 3 over -4 or -3/4. Again, this is giving us another ordered pair that's on my graph. And now I know the ordered pair when x is 0, -3/4 is going to be on my graph. So we have 2 ordered pairs that are on our graphs at this point by finding the x and y-intercept. The last thing that I want to find, the last 2 things I want to find are any vertical asymptotes and any horizontal asymptotes. Well, let's take a look at the vertical asymptotes. So this is part C. Remember that the vertical asymptotes are the domain restrictions. So what we want to do is we want to look at the denominator and see what values would give us 0. And that's why factoring it's really helpful. So when I look in the denominator over here, I have x minus 2 times x plus 2. That means I have 2 zeros in the denominator, one at +2 and one at -2. So I have 2 vertical asymptotes. I have one at 2, and I have one at -2. When we go to graph these, which we'll do in a few minutes, we would put vertical lines, little dashed vertical lines up there to represent that our graph can never cross through these 2 lines. So these are the infinite walls we were talking about before. And last thing I want to concern myself with is any horizontal asymptotes that I may have, and I'm just going to call horizontal asymptote HA. Horizontal asymptotes, now we're going to use the degree. So I'm going to go back and look at my original function, which is x plus 3 over x squared minus 4. The degree of my numerator is 1, right? That's x to the first power, so I have linear in the numerator. In my denominator, I have quadratic, it's 2, so I have x squared in the denominator. The degree of the numerator is smaller than the degree of the denominator. That means I'm going to have a horizontal asymptote at y equals 0. So that's it for this example. Let's try one more to make sure that you understand everything we're talking about. And the last one we're going to do for this example, and then we're actually going to graph the next few ones, is h of x equals 3x minus 2 over 2x plus 5. In terms of factoring it, linear, not factorable, so we don't have to worry about factoring it. So let's go right on to the x-intercepts and the y-intercepts. They're not factorable any further under the reals. So let's go on to the x and the y-intercepts. Well, for the definition of the x-intercept, again, it's 0 of the numerator. So what we're going to do is we're going to go to the numerator, which is 3x minus 2, set it equal to 0. We would add 2 to each side. We get 2 is equal to 3x, divide by 3. So we have an x-intercept at 2/3, which is telling us that one of the ordered pairs that's on our graph is 2/3 0. Let me just put this up here, sorry to separate this. Let's move on to our y-intercept, and again for our y-intercept, we're going to let x equal 0, so we're going to substitute in 0 every time I see an x. And we get h of 0 equals 3 times 0 minus 2 divided by 2 times 0 plus 5. And that's going to leave us with 3 times 0 is 0 minus 2 is negative 2 in the numerator. 2 times 0 plus 5 is 5 in the denominator. So we have a horizontal asymptote, we have a y-intercept at negative 2/5. And the definition of the y-intercept is when x is 0. That's what we substituted in for it. So again, this is giving us two ordered pairs that are on our graph, the ordered pair 2/3, 0, and the ordered pair 0, negative 2/5. Let's move on now to the vertical asymptotes and the horizontal asymptotes. For the vertical asymptote, I'm going to ask myself, what are the zeros of the denominator? Right, those are our domain restrictions. Now we only have, we have a linear function in the denominator, so we're going to have one vertical asymptote. And 2x plus 5 equals 0. Subtracting 5 from each side, dividing it by 2, that means x is equal to negative 5 halves. Knowing that x is equal to negative 5 halves, that means we would draw a vertical line at negative 5 halves, a dashed vertical line at negative 5 halves to show that our graph can't pass over there. In terms of horizontal asymptotes, now we're going to take a look at the degree. In our numerator, we have a first degree. In our denominator, we have a first degree. So that means the degrees are the same. Anytime we have the same degrees, we're going to take the ratios of the leading coefficients. So our leading coefficient here is a 3. Our leading coefficient here is a 2. That means we have a horizontal asymptote, and y is equal to 3 halves. And we draw a horizontal dashed line at 3 halves.